Hello, my name is Penkauskas, and today I'll be presenting my undergraduate research project, which is in review, titled Hogs and Hazelnuts, Adaptively Managing Pest Spillover in the Agricultural-Wildland Matrix. First, I'd like to thank my mentors, Dr. Lauren Hallett and Alejandro Brambila. I've had the privilege and honor to have had their guidance and grace over the last 3 years, and I can't thank them enough. To start, agriculture in the United States tends to rely on industrial processes and is dependent on pesticides. While these practices are effective at removing resident populations of agricultural pests, there are many cases in which pests can spill over from unmanaged areas within the landscape onto farms. This is the case in Oregon, where a booming hazelnut industry is threatened by the filbertworm, a native moth that can destroy over half of the potential production and whose native host is the Oregon white oak. Less than 5% of the Willamette Valley's historical oak habitat remains, and what is left is dispersed throughout a matrix of developed agriculture. Almost all of the hazelnuts grown in the United States are grown in Oregon's Willamette Valley. Additionally, hazelnut production in Oregon is expected to double in the next 15 years, further straining conservation efforts of oaks as more oak habitat will be in conflict with hazelnut growers. We were interested in investigating management techniques that could adaptively decrease filbertworm populations in otherwise unmanaged oak woodlands. As such, grazing is a promising tool for managing woodlands that helps align conservation principles and economic goals. Hogs have historically been used to graze acorns from oaks in other parts of the world and create a highly desirable non-timber forest product. To test whether hogs were effective at reducing filbertworm populations in oak habitat, we worked with a local family farm that is currently transitioning from annual grass seed production to a diversified ranching system. Hog grazing was prescribed during early fall when the filbertworm larvae are still in the acorns but were aborted by the tree and have fallen to the woodland floor. We conducted an experiment in a remnant oak woodland at my brother's farm in Creswell, Oregon. We established 4 2-acre paddocks in which hogs were allowed to graze between 4 to 5 days in each and then rotated into the next. We also established a control area and monitored filbertworm with emergence traps on the woodland floor. Additionally, I surveyed acorns before and after grazing each year. Before we grazed in 2018 and 2020, we sampled vegetation cover along transects in the paddocks and control area. This was done to see to what extent grazing had disturbed the woodland understory over the course of 2 years. In short, the hogs loved finding and eating all the acorns. Didn't matter too much if they were infested with larvae or not. To our surprise, though, the hogs did not have the effect on percent cover of vegetation that we thought they would have. Bare ground did not increase between 2018 and 2020, so the given stocking rate may have been ideal. Filbertworm populations in the grazed paddocks diverged from the control over the course of 2 years, with a significant difference in 2019 and near zero filbertworm emerging in the grazed paddocks in 2020. Although some of this can be contributed to oak masting and interannual variability, we can see that multiple years of grazing did in fact decrease filbertworm populations compared to the control. This is exciting because there's an increased commercial demand for more nature-friendly pork, and if this strategy can be scaled up, there could be a decrease in potential for filbertworm pest pressure on nearby farms, creating a win-win scenario for both oak conservation and hazelnut production in Oregon. Although hog grazing may not be practical in every case, other tools like prescribed burns and other types of grazers, such as goats, could be used contextually to manage these woodlands and further reduce filbertworm pest pressure. These tools could synergistically help landowners adapt to an increasingly variable climate and to changing economics of the future. I would like to take a moment to thank everyone at My Brother's Farm for all their help facilitating this project, and everyone in the Hallett Lab for all their help workshopping my thesis. Lastly, I'd like to thank the Center of Undergraduate Engagement, the Undergraduate Research Opportunity Program, the Environmental Studies Program, and the Center of Environmental Futures. And of course, thank you all for your time.